Good morning, class. Today we are continuing our lesson in antiderivatives. We have a whole bunch of new rules, most of them having to do with trigonometry and e to the x. Please pause the video here so that you can copy down these new rules. In the bottom, we're starting with some examples. The first one has e to the x in it. If you remember from previous days when we've got an equation that looks like number 8, we are going to separate out the constant so that the problem looks like 5 antiderivative of e to the x plus, dx plus 2, and then the integral sign, and then dx. So looking at our rules above, when you've got the antiderivative of e to the x, it is also e to the x. And the antiderivative, when we have a constant in front of the integration sign and nothing except dx, that means it's going to be linear, so it's going to be plus 2x. And then we always have our constant to indicate that it is a family of functions. Number 9, we're going to use our previous rules to separate out, to do the antiderivative separately of the two functions after the integral sign. So the first one is going to be separated to look like this. Second one is going to be separated to look like this. And now we're ready to do our antiderivative. If we look above, the antiderivative of sine squared x, antiderivative of sine squared x is number 6, the rule above. Number 4. And so it's going to be 3 tan x plus our rule with a linear is going to be multiply the constant, add 1 to the exponent, and then divide by the same exponent and add c. Simplified is 3 tan x. 4 divided by 2 is 2. 1 plus 1 in the exponent makes it 2. And c for our constant. Number 10, I recommend multiplying it out first and then separating. X to the 4th times 2x cubed is 2x to the 7th plus, and then with any kind of variable in the denominator, you want to move it to the numerator and make that exponent negative. Now we can separate it into two antiderivatives. 2 x to the 7th dx plus 3 integration of x to the negative 2 dx. Take them separately. 2 x to the 7th plus 1 over 8 plus 3 x to the negative 2 plus 1. Negative 2 plus 1 is negative 1. So we divide by the new exponent, and then we always add c. Simplifying 2 over 8 becomes x to the 8th over 4. The negative 1 multiplied by the plus sign in the between the two functions makes it negative. 3 stays in the numerator. X to the negative 1, which is our new variable, goes to the bottom of the fraction, and of course the exponent becomes positive plus c. Okay, when we started studying antidifferentiation, we recall that when I am given a function, small f of x, there is some original function, capital F of x, that shows that it is the derivative of the function given. So when I've got my antiderivative, an interchangeable word is indefinite integral. And they want to remind you that that function represents a family of functions. So this is why we are always adding c at the end. Right? So if I end up with a derivative of 3x squared, I could have started with x cubed plus 4, x cubed minus 7. All of these came before this function as a derivative. So doing exercises 1 through 7, it says find the antiderivative. So basically they are saying the integral sign for the function given. It's like putting this sign in front. So if I start with little f of x, what came first was capital F of x. The antiderivative of 3x squared is 3x, add 1 to the square, it's cubed, divided by the new exponent, minus 4, it's x to the first, so now it's x to the second, divided by 2, plus if I've got a constant by itself, that is going to be made into a linear term, and then we add c. This is going to simplify to x cubed minus 2x squared plus 5x plus c. Number 2, I want what came before this as a derivative. The antiderivative of e to the x is e to the x. Antiderivative of 2x is positive 2x. It was previously to the first, now it's to the second power. Always divide by the new exponent plus c. Final answer is e to the x plus x squared plus c. Number 3, what came first? The 5, so the coefficient always stays. The antiderivative of sine x is negative cosine x. And then our negative 3x becomes negative 3x. It was previously to the first power. Now it's to the second power plus c. You're just going to want to move that negative to the front in the first term. There is nothing to simplify in the second term. Final answer is that. Number 4, you're going to want to multiply first before you do the antiderivative. So it's going to be 9x squared plus 12x plus 4. Oops, that's supposed to be a 4. So what came before that function? 9x squared becomes cubed, divide by the new exponent, plus 12, it was x to the first, now it's x squared, divide by the new exponent. The constant becomes a linear term plus c. These need to simplify to a coefficient of 3. These need to simplify to a coefficient of 6 before the x squared. 4x is fine. Number 5, 4 pi is a coefficient. So you're going to leave that in front of what was your original function. The antiderivative of cosine x is positive sine x plus c. Last one on this group. What came first before that function? Capital F of x. 3/5 is our coefficient, so it stays in front. X to the 2/3, I'm going to add 3 over 3 because that's adding 1. If my new exponent is 5 over 3, that's what I'm going to divide by. Minus 3x becomes minus 3x squared over 2 plus 1x plus c. Simplifying our term in front, 3/5. And then I'm going to multiply by 3/5 because this flips and then multiplies. X to the 5/3 minus 3x squared over 2 plus 1x plus c. Last simplification is 9 over 25 x to 5 thirds minus 3x squared over 2 plus 1x plus c. Okay, the last 6 problems. Number 7, separate your antiderivative into 4, and then the antiderivative of secant squared x plus 3 forgot the dx. Why I always forget the dx. 3 times the antiderivative of dx. Our answer is going to be 4 tan x from our new rules, plus, if I've got a constant in front of an integral sign with no variable afterwards, it's going to be 3x, because we're going to make it linear. It was almost like this was x to the 0, so I added 1. And then I'm going to have plus c. Number 8. Separate them out. 3. Integration of x squared dx minus, that square root of 5 is your coefficient, so it goes in front. So inside the integration sign is just x dx plus 2 antiderivative dx. So normal rule or power rule, simple power rule for the first one, 3x squared becomes 3x cubed. Add 1 to the exponent, divide by the new exponent, minus square root of 5. X to the first becomes x to the second divided by 2. 2 in front of the integral sign with no variable is like x to the 0, so it's going to be 2x. Because I'm adding 1 to 0, I get 1. Divide by 1, it still leaves 2x. Plus c. The only thing we'd have to do here to simplify is divide 3 by 3 to get x cubed as the first term. For the next one, separate them out. So I would take 1/3 in front of the derivative sign. I would change 1 over x cubed to x to the negative 3 dx minus 3 halves antiderivative of x to the negative 2 dx. So I'm going to have 1/3 times x to the negative 3 plus 1. Negative 3 plus 1 is negative 2 minus 3 halves. X to the negative 2 becomes x to the negative 1 divided by negative 1 plus c. I'm going to continue this down here so I have more room. I'm going to simplify the first term to be negative 1 over 6, because 3 times the negative 2 move the negative to the top. X to the negative 2 means that x squared is going to go in the denominator. Negative 1 over here times negative 1 is positive 1. 3 over 2. X to the negative 1 goes in the denominator as positive x plus c. That's the final answer for number 9. Number 10, distribute the x cubed first before you do the antiderivative. So you end up with 2x to the 4th dx plus the antiderivative of x squared dx. So 2x to the 5th over 5 plus x to the 3rd over 3 plus c. Final answer for number 10. Again, with number 11, you're going to distribute the x to the 5th. Now you're going to do the antiderivative, 3x to the 7th dx plus the antiderivative of x squared dx. 3x to the 8th over 8 plus x cubed over 3 plus c. And then our last one, you're going to simplify first. X squared minus antiderivative of x plus 5 x to the negative 2. And don't forget